Hello, hello. Here we go with chapter 7, second to the last chapter. Okay, so we are covering 7.1 in this video. I will break it up into two parts. The first part will cover square roots, and then the second part we will cover cube roots. Okay. All right, so take notes. 7.1, radical expressions. Okay, so starting off with square roots. You should be pretty familiar with square roots. Okay, so the number b is a square root of a if, when you square b, you get a. Okay? And we use this symbol here to represent the positive square root. We also call this the principal square root. So aka principal square root. Okay. And then we use this one to represent the negative square root. Okay. So let's take a look at evaluating square roots. So let's go ahead and evaluate the following. Let's do square root of 81. What is the square root of 81? Very good. Did you say 9? Okay. And what is this negative square root of 225? Anyone know what that is? Kind of a high number here, 225. Okay, so this one here, if you said negative 15, you are correct. Okay, and let's take a look at this one here, fraction 49 over 4. Okay, so what do you think the square root of this is? Okay, if you said 7 over 2, you are correct. So when you have a fraction here, just do the square root of 49. That would be 7. And then do the square root of 4. That would be 2. Okay, so 7 over 2. What about this one? Let's see if any of you can get this one. What about 0.36? What do you think that is? Okay, we have 2 decimal places there. So if you do 0.6 times 0.6, you will get 36, and then you'd have to move the decimal 2 places. Okay. All right. Very good. Okay, so let's take a look at square roots of variables. So here, all of these were just numerical expressions. So let's take a look at some with numbers and letters. Okay, so square roots of variables. For real number x, the square root of x squared is equal to the absolute value of x. Okay? All right, so let's take a look. Let's evaluate the following. All right, so if I have this one here, square root of 16x squared, we do have a variable there. So square root of 16 is 4. And then we have this situation up here, square root of x squared. So we're not going to just write 4x. We have to write 4 times the absolute value of x. Okay? So just keep that in mind when you have the variables. Okay, so let's take a look at this one. Suppose I have t squared plus 2t plus 1. Okay, so we have to do a little bit of work here because we're trying to find perfect squares, and this is one expression, so you can't just do the square root of this t squared here. It's the square root of the whole thing. So what we need to do first is factor this expression. So let's go ahead and do that. And if we factor it, we get t times t to make t squared. Signs are going to both be positive. There's only one way to make 1. 1 times 1. And then if you check the middle term, that does give us 2t. All right. And we have repeated factors here, t plus 1 times t plus 1. So then now I can go ahead and just use exponents to represent that repeated multiplication. And now I do have a perfect square, but I do have a variable here in this expression. So I can't just write t plus 1 as my answer. I have to do absolute value. Okay. All right. Let's take a look at this one. M to the 6th power. Okay. So here, again, we want perfect squares. Another way you can look at this is m cubed is being squared, right? Because when we have power to a power, we multiply the exponents. Okay, so that would be 6. Okay, so here we do have a perfect square now. M cubed is being squared. So here, again, we can't just say m cubed is our answer. We have to say the absolute value of m cubed. Okay. And let's take a look at this one here. This one, 49 r to the 8th. Okay, so we already know that's going to be 7. And then here, let's go ahead and rewrite that r. Okay, so this is 49. And another way to write this is r to the 4th squared, right? Okay, so here, 49, not 49, 7, r4 is our answer. And here, we actually do not need absolute value symbols. If you put them on, it's not going to hurt, but we actually don't need them here, okay? Because the reason why we put them here to begin with is because we don't know if x is a positive number or a negative number, right? And we know that we said here at the very beginning that this represents the positive square root. So we want the positive result. So over here, if we don't know what x is, and we just leave x as our answer, like over here for letter A, let's suppose that you said, oh, my answer is 4x. Okay, well, what if x is -2, right? Now you end up with a negative answer, not a positive answer. Okay, so since we don't know if x is positive or negative, this is what we do here. We put on these absolute value symbols to ensure that we're talking about the positive result, not the negative result. Okay, now, and so we do that here because we don't know if t is positive or negative, or t plus 1 is positive or negative. Same thing here with m. But here we don't need to, because let's suppose r is a negative number. Okay, so like -2. Okay, if we do -2 to the 4th power, what do we end up with? A positive result. Okay, so here, because we're raising it to the 4th power, we're going to end up with a positive r result. Okay, because anytime you raise anything to even power, you'll get positive as far as real numbers go. Okay, all right. Let's take a look at graphing square roots. Okay, graphing square roots. Okay, so let's take a look at the parent function. So we have that one unit on parent functions, and we looked at how to graph them by shifting. We're going to do the same thing here. So we're going to look at the parent function. F of x equals just your very basic square root x. Okay, and then we'll take a look, oh, what happens if we have something like this? Okay, how do you graph that, right? Okay, but let's first look at the parent function. Okay, so let's go ahead and take a few values just so we can see where this graph comes from. All right, I'm going to choose some x values. 0 is always nice. When I plug in 0, plug in 0 in here. Square root of 0 is 0. Then I'm going to choose 1. 1's kind of nice. So when I plug 1 in here, square root of 1 is 1. These are all values you can do in your head, but I'm going to go ahead and write them out here in the table. And oftentimes we choose -1, right? But we don't want to take the square root of a negative number because we'll end up with imaginary. So I'm not going to choose -1. Oftentimes we choose 2, but I'm not going to choose 2 because I don't want to do the square root of 2, which is some decimal number. Okay, and I'm not going to choose 3 either because 3 is not a perfect square. I'm going to choose 4 because I know what the square root of 4 is. Square root of 4 is 2. Okay, so these are going to be my 3 points. These are going to be like my reference points for when I graph the other graphs through shifting. Okay, so I have a point at 0, 0. I have a point at 1, 1. And I have a point at 4, 2. 1, 2, 3, 4, 2. Okay, and so what happens is you have this graph that looks like this. Okay, and what you're actually graphing here, let me show you. So what we did was graph this, right? Now, if I square both sides, I get this, right? So what you're actually doing is graphing a sideways parabola, but only the top half, since when we do the square root, we're only talking about the positive results. So that's only the top half of this sort of sideways parabola. Do you see the sideways parabola now? Okay. And again, we only want the top half, the positive half. This would be negative square root x that we're graphing. Okay. All right. Okay, so these are going to be our 3 basic points, and then we're going to be shifting them. So let's take a look at graphing something a little more complex. Let's go ahead and graph f of x equals square root x plus 1 minus 2. Okay. All right, so it's gonna be this exact same function, except it's going to be shifted, and it's going to be shifted 1 unit to the left, and 2 units down. Okay. All right, so when I graph this, I'm going to have those 3 points, those 3 basic points that I just plotted in the parent function. Okay, here, I want to do this over because I have all this space. So I don't want it to be so crowded. Okay. All right, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay. All right, so in that previous graph, my parent function has a point at 0, 0, 1, 1, and 4, 2. Okay, so this is my parent function. And then I'm going to go ahead and graph this, shift this 1 to the left and 2 down. So 1 to the left. So each of these points, so I'm going to start with this one right here at the origin. I'm going to shift it 1 to the left and then 2 down. Okay, so that would be right here. I'm going to do the same thing with the second point here, 1 to the left and then 2 down. And then same thing with this one over here, 1 to the left and 2 down. Okay, and then my graph would be this one right here. Okay, so these are the 3 basic points of the parent function that you need to know. And if you don't memorize them, that's fine. You could always just make a table of values for the parent function. Choose nice x values, x values that you can take the square root of. Okay, go ahead and try this one. I'm going to throw an outside number. Okay, so see if you can get this graph. G of x equals -1 times x minus 2 plus 1. Okay, all right, go ahead and hit the pause button. Okay, so this one, if you recall, this is going to multiply the original y values. This will shift it 2 to the right, and this will be 1 up. Okay. All right, so one, two, 1, 2, 3, 1, 2, 3, 4, 5. I might need this to go a little bit longer. Okay. All right, parent function. Here, I'm going to do it with blue. All right, parent function 0, 0, 1, 1, 4, 2. Okay. So that's my parent function. All right, and now I'm going to multiply those y values. Let me do that in purple. Okay, so I'm going to multiply the y values by -1. Okay, so 0 is the y value for this point. 0 times -1 is 0. This y value is 1. So 1 times -1 is -1. So now this is going to go down here. New y value, -1. And this has -2y value, positive 2y value times -1 will give you -2. Okay, so now I have this graph, these purple points here, and I'm going to shift them 2 to the right and 1 up. 2 to the right and 1 up. Let me use green. Okay, 2 to the right. So I'll start with this one here at the origin. 2 to the right, 1, 2, and 1 up. Okay. 2 to the right, 1, 2, and 1 up. This one goes 2 to the right and 1 up. And that would be your graph. Okay. Okay, so that's how you graph these. Just use that parent function and then do all of the shifting that we learned about in the earlier chapters. All right, let's talk about domain, and then we'll end there. Okay. All right, finding domain algebraically. So we can already see that we do have a restriction. We can't just take the square root of any number, right? We want to take the square root of positive numbers, because if we do the square root of like -1, then we don't get a real answer, we get imaginary, right? Okay, so we already can see that we have restrictions here. So let's take a look at this. Suppose I have this function, f of x equals square root of x plus 3. Okay, so we don't want to take the square root of a negative number, right? We don't want this to be negative. Okay, so let's go ahead and write that down. So here, we don't want imaginary results. So we don't want negative under the radical. Okay, under the square root. Okay, so what we do want is for x plus 3, this thing that's inside the square root, we want that result, we want this result, x plus 3, to always be 0 or positive, right? So greater than or equal to 0. Okay, so that's pretty much what you do. You just say you want this, and then you solve for x. So we subtract 3 on both sides, and we get that x is greater than -3. So that's your domain. You can only use x values that are greater than or equal to -3. So like -4, you cannot use. -2, you can use. Okay. And if we write that, so here, this is what it looks like on a number line. Here's -3, greater than, so we'll do bracket, and we'll shade this side. And so that is in this form, it would be -3 to infinity. Okay. So find out which way they want you to write it. I'm pretty sure it's going to be this interval notation on WebAssign. Okay. Okay. Let's take a look at this one. Suppose that you have this function, g of x equals square root of x minus 2. Again, we want that inside to be 0 or positive. So we want this x minus 2 to always be greater than or equal to 0. So if I solve this, then I find out that x has to be greater than or equal to 2. That's your domain. Greater than or equal to 2 looks like this. Here's 2. Greater than or equal, so we'll do that. And we'll shade this way. So it's going to be 2, comma, infinity. Okay. And go ahead and try this one. H of x equals square root of 2x plus 7. Okay, so go ahead and find the domain here. Hit the pause button and come right back. Okay, so we want 2x plus 7 to be greater than or equal to 0. If I solve this, I get 2x is greater than or equal to negative 7. And then I divide both sides. So x is greater than or equal to negative 7 halves. Okay, so if I do that, here's negative 7 halves. X has to be greater than or equal to that. So it's going to be negative 7 halves, comma, infinity. Okay. All right. If you have any questions about that, just make sure you text me or email me. That's part 1 of 7.1. Stay tuned for part 2.